Okay, in this video, I'm going to show you how to connect motion diagrams to position time graphs. And the reason you might want to think about this is maybe you're particularly good at drawing motion diagrams. Like you can take a situation like a zebra running across the plains, and you can figure out pretty easily what the motion diagram would look like. But maybe you struggle with what the position time graph would look like. So if you can do the motion diagram, you can do the position time graph if you connect the two of them. And so that's what we're going to try to do here. So a zebra runs pretty fast. They actually run about 40 miles per hour. So in my example, I'm just going to make a quick motion diagram for the zebra. All right, so here's the zebra at time 1, 2, 3, 4, 5, 6. Let's just do like that. All right. And now let's put in the velocity vectors. So they're all going to be the same length because they represent the same velocity, 40 miles per hour or 20 some meters per second. All right, so there's my motion diagram for the zebras, for the zebra running across the plains. Now let's say we want to make a position time graph, but we're not entirely sure what that's going to look like. So what we're going to do is we're going to come and grab the motion diagram, and we're going to scoot that up and rotate it so that the first dot is down near the bottom axis right here. And then we're going to make a graph using the motion diagram. So at time 0, there's where a point would be. And then at time 1, then that's the next moment in time, and the next moment in time, and the next moment in time, etc. Like that. And always we can see the dot and the time moment line up. The dot from the motion diagram lines up with the moment of time. And then we can just do like that. And we see it's a nice linear graph, which is what we'd expect for a object moving at a nice steady speed. Now, what would happen if the object is not moving at a steady speed? All right, so in this example, we're going to imagine, we're going to take a look at a graph, position time graph, for a bowling ball that's falling here, falling down like this, and it's going to hit the trampoline, and the trampoline is going to stretch from here down to here where the bowling ball comes to a stop. So we are going to motion diagram this portion of its motion right there, from when it hits the trampoline to when it comes to a stop. All right, so in this case, the ball is moving really fast before it gets to the motion diagram, to the trampoline, and then the trampoline slows it down. Okay, so then the next set of dots have to be less close like that. So that shows it, the object slowing down. Now let's put in the velocity arrows, velocity vectors. All right, so going really fast, slowing down even more, and then stopped. Okay, so now what will the position time graph look like? So here's our position time graph. So we'll have time here, and then we'll have position here. Let's just say X for position. Okay, so let's again grab our motion diagram, and let's rotate it so that it goes along the X-axis, or excuse me, the Y-axis, the position axis. Get that straightened out here. There we go. All right, so there's the motion diagram lying along the position axis. Now we're going to make our graph from that. So at time 0, it's right there. At time 1, 2, 3, let's go like that. So at time 1, it's right, its position is there. At time 2, its position is there. And at time 3, its position is there. Now, what you might be able to see is that that's not straight at all. That's curving like that. And in fact, that's what we would expect for a position time graph for an object that's slowing down. It would have a steep slope here and a less steep slope here and even less up there. So yes, the position time graph can be made by thinking about the slope, but again, it can also be made by simply making a motion diagram and translating that up into the position axis of the graph.